Yeah, Larry Trunick with Miller Coors. Question was for Stewart. We really are interested in that development that you're working on, trying to get the energy out of all the equipment. Question we've got, though, is do you count the fleas on the dogs in the parade or the dogs? You know, how granular do you go after that data?
We let the first couple of plants that worked with us help us define the global standard along with our partnership with Schneider to develop the standard. I personally believe that the lean trigger has to be at an asset level. You have to allow, for instance, let's take drying tissue. You can use more heat out of the burner and less flow of air from the fan, put the same amount of BTUs in the sheet. But if electricity is really a high cost and gas is really a low cost, you're going to lean toward the gas, right, instead of the electricity. If you're somewhere else and electricity is cheap, you may use more fan and less natural gas, particularly if you're not on a natural gas line. So as far as both the triggers and the overall balance of energy optimized for cost, I just want to know that they're at their plan at an overall machine level and then let them manage within that. I think being able to drill down into the sub-level of meters and set targets at the sub-asset level is very important, but I would let your teams do that based on where they think they can drive the value. So I don't know if that's the answer.
The real question, I think it goes beyond that in saying, where do you cut it off? You know, a 60 amp asset, or do you think you cut it off at a 500 amp asset or a 1,000 amp asset?
Well, the answer to that question in Kimberly-Clark was we wanted to be able to create a relevant benchmark level. So you want to be able to compare an asset in one place to an asset in the other place. Where that loses identity, where it's too low a level and it loses its identity and can no longer really be relevant to compare in one place to another place, I think you've gone too far. So we draw it at really the manufacturing asset-based level to do the benchmarking.
Thank you.
I don't know, Kevin, did you want to say something to that as well? Maybe some of your observations with some of your other...
Yeah, I guess the only thing I'd add to that is we kind of feel like it's important to make sure that the benchmarking and the data that you're gathering around with the energy is something that the operations team for that area can do something about. You know, if it's beyond their control to do anything about it, you know, then it's not as important to do that. And in most cases, it's okay when you're forming this machine, this envelope machine around things, that you can get it pretty well. But that's the trick to it, is to balance those things out around an operational area.
All right, thank you. Question for Stewart. You mentioned a little bit, you didn't show us the statistic on the energy per unit, obviously for very good reasons. Have you thought about the process where getting to that point by looking at maybe the different pieces of equipment or machine that make up the line and then tying it into, like, let's say your process order to try to figure out, you know, how do I get it to a step further by tying in order information or potentially other type of attributes, as Sal mentioned, I don't know, maybe a maintenance order, something like that. Have you thought through that process to get it to that point? You mentioned a little bit about what you're doing right now with some of your goals, but what is that next step after that? You're doing the rollout, but what about tying it in from a unit perspective? Because I think getting to the unit perspective seems that you have to tie in a lot of other data elements.
Well, I think that we're already seeing in a couple of sites that are doing this the need to tie preventive maintenance instructions, particularly around checking to make sure that the levers which would hold an asset at its target planned amount of energy use are being followed. So they're making that connection, but we do that in a separate, ERP process driven toward, production maintenance planning, which is separate really from the dashboarding or accountability process here. I would say we haven't gotten very far to that next step yet, but I think it's coming, and I think that the integration of understanding how to prevent the red condition from occurring will happen as we start to see Paretos of those red events. It happened everywhere else when we implemented Lean. So nobody wants to have 4 quality excursions in a week. And once you start Paretoing them and you see how fast they occur and how often the root cause is the same root cause, you start to go, okay, how do we prevent that root cause? But you have to have the problem consciousness from the Pareto to drive you to the prevention step of preventing the root cause. So I think it's probably phase 2.
If I might add, maybe, Manuel, you want to respond to that a little bit? Because there may be some connection between trying to correlate other aspects of what you're trying to measure now with other activities in your operation. Do you want to speak to that at all? I know it's not energy related in your operation, but it could be the issue of how do you tie, orders to improving, other aspects of your production operations or testing operations to the things you. Go ahead.
Without you're using Paretos and all that, right? And or the dashboards, right? What I would tie to that is the perspective how we're using the test
closely. Put it close to your mouth.
The perspective of the test data we're using to drive, decisions with our engineering group, right? And also during our tests. So sometimes, when we're testing and the product starts giving you specific signatures that it's gonna go away. And that product is very difficult. It's a one-time, prototype unit. You need to make sure that data is that trend. We follow it and we make sure we stop the test prior to bursting that unit or breaking it in the stand, right? So we test with natural gas and we use that. And obviously, all that consumption is something we need to be careful about. All the cycle associated and cost associated to restarting a test is something we're concerned about. So that's how I would use it.
Okay, great, thank you.
While he was talking, I thought of one other thing from an order-based perspective. As we grade change from one product to another or come up from a down, we were allowing the process to go through its startup center lining, and they would start all components of the asset long before the production started. In fact, we would reward who could start up the machine the fastest. We turn on the hoods. We wanted OEE, so nobody wants to be responsible for delay when you finally get to the point where you're pressing the button and creating the go condition, right? So we were actually stroking the idea that we'd start the whole machine and burn energy until we're ready to go, right? So since then, we've changed the standards around startup. We're saving some $75,000 a year now by starting the hoods 15 minutes before we actually put a sheet on versus, in some cases, an hour and a half before we turn the sheet on. We never would have been able to do that without the dashboard tool that said, hey, here's how much we lose in a year if we keep the hoods running with no paper coming through for these, this amount of time before we put a sheet on. So it's changing the standards around that process order in that we won't start certain components that overconsume energy until just in time, just before you need them. So I don't know if that also is part of your answer, but it's happening, I'd say, ad hoc right now across our standards for a production order.
Mm-hmm. Excellent. Josh, would you like to comment on some of this as we get in on this conversation?
The only thing I would add to that, too, is we've seen it in the CNC world as well, where you've got a lot of older CNCs, and what people will do, they'll start them up to do warm-up cycles, so they're ready to go. And then you find out that they've been running warm-up cycles for an hour and a half, and you really needed 15 minutes, and that was it. So by tracking these types of things, you find out very, very quickly, and tracking really some basic information and just what is this downtime. It's a warm-up cycle, and you see how long that's going. You can tie that back to some savings and some energy savings very, very quickly, again, with some very, very basic data collection and analysis of that data.
All right, thank you. So, any other questions?
Hi. Do you expose the time of day billing cycles to the operators? The fact that evening rates are much lower than peak times during the day, and the peak charges that occur during the course of a month. There's a lot of complicating factors that add into your utility bill. Do the operators see that? Are they exposed to that?
Currently, in the facilities, I'll take Southern California, where I was the facility manager just recently. Peak demand charges are very impactful. I would say in a macro level, the only thing we're left with, because you don't have the real-time dashboard prior to this implementation, you would let them know that, you know, if the machines go down, we don't want to start up during certain bandwidths of time when you're at peak demand. You would actually stay down. So you're making the management decision for them, and you can't really manage your peak demand lower because you don't have that real-time dashboard to them. What we're learning now in Koblenz, Germany is our first facility. They've significantly reduced their peak demand charges through use of analytics to try to reduce the peak demand during those times that they're measured. And they're doing so by making their dashboards be time-based so that the targets actually change during those times. And they will offload or turn off load, exit load during those times that they don't need to critically be running, and turn it back on during off-peak times to manage their peak demand lower. So it's not necessarily through this real-time lean operator at the floor. It's through the same use of dashboards at a facilities management level, where they might turn off a set of compressors and exist in a suboptimal state for compressed air, let's say, where they might already have a reservoir of compressed air to use, rather than run those compressors during that time and try to exit load that way, non-critical equipment.